Good morning to all. Today we are going to see about the subject neural networks and deep learning. The subject code is 191ITV66. From this subject we are going to see about introduction of neural networks from unit 1. So this is the outline of the presentation. So first we are going to see about the introduction, ANN, then introduction to artificial neural networks, evaluation of neural networks, basic models of artificial neural networks, and then application of neural networks, then activation function using in the neural networks. See, then in introduction, the neural network is a machine that is designed to the model in a way in which the brain performs a particular task or function of interest. The network usually implemented by using electronic components or simulated in software on a digital computer. To achieve good performance, neural networks employ a massive interaction of simple computing cells referred to as neurons or processing unit. Here, the neurons are represented as the cells which is presented in human brain. So, replicate the neurons, we are going to use the perceptron in ANN, artificial neural networks. See, this is the image of neurons which is present in our brain, in human brain. The neuron has three portions. First one is dendrite, then cell body and axon. The dendrites are known as the input to the neuron, which is getting the data or information from outside and give it to the neuron. Then in neuron, the cell body is doing the processing of the information, and then axon give the output to the neuron. So through axon, the after the process, the output is sent through the axon. Then it is known as output signal of the neurons. So here dendrites is used to receive information from other neurons that is connected to the neurons. Then cell body, information processing happens in the cell body. This take in all the information coming from the different dendrites and process that information. Axon, it sends the output signal to another neuron for the flow of information. The it give the output as a input to the other neurons. That is, dendrites are the hair of the next one. Then artificial neural networks. Here we are going to represent the artificial neural network, which is replicate the structure of a human brain cell, that is neuron. So here also we are having inputs layer as dendrites, then hidden layer as cell body, and output layer as axon. So here the input layer get the information or get the input from outside, and then hidden layers are doing the function or process the information. Then output layer give the output of the particular process, and then which is act as the input to the other neuron also. So this structure is simply called as perceptrons. So a neural network is a system of hardware or software patterned after the operation of neuron in the human brain. Neural networks, also called artificial neural networks, are a means of achieving deep learning. So the network is started from the input layer, and then the lines are connected to the each and every node of the input layer to every node of the hidden layers. Then hidden layers do the processes the input, and it puts the output into the next hidden layer. Then at last the output layer combining the processes input outputs, and then giving a output to the of the particular process. So this is how we can implement this one is it is the replicate of the human brain cell, that is neurons. So it is simply called as perceptrons. Perceptrons is a machine learning algorithm for supervised learning techniques. It uses the binary classification technique task. A perceptron is also understood as a artificial neuron or neural network that helps to detect certain input data computations in business intelligence. A perceptron model is also treated as one of the best and simplest way of the artificial neural networks. It is a supervised learning algorithm of binary classifier. So we can consider it a single layer neural network. It represents the four main parameters, that is input values, weights, bias and net sum, and then activation function. So this is the image representation of perceptron versus neurons. So here we are going to see the brain cell, that is neuron. Then the representation of the neuron as in artificial neural networks, which is called as perceptron. This is the image of both perceptron and neuron. Next, the evaluation of the neural network. That is, here we are going to see about the basic components of a perceptron, which is the replicate of the neurons. Mr. Frank Rosenblatt invented the perceptron model. A binary classifier comprises three main components, which is represented in perceptron. The first one is input, and along with its weights, then input function, then activation function, and then it gives the output. So each and every inputs has its own weight, and then we are combining the inputs along with its weights, and we are using the summation function, and then in activation function we are using the bias plus input function of the net input function, and then we are bringing the output. So here we are going to see the each and every components of the perceptron. First, input nodes are, which is called as input layer. This is a primary component of perceptron which accept the initial data into the system for further processing. Each input node contain a real numerical values, weight and bias. Here weight parameter represent the strength of the connection between the units. This is another most important parameter of perceptron components. Weight is directly proportional to the strength of the associated input neuron in deciding the output. Further, bias can be considered as the line of intercept in a linear equation. Then activation function. These are the final and important component that help to determine whether the neuron will work or not. Activation function can be considered primarily is a step function. We are having more activation function, but basically we are using the step function in activation function. And here we are going to see the types of activation function. Here we are having three main activation function. First one is sine function, then step function, third one is sigmoid function. In step function, the input is starting from 0 up to 1. Here we are having input and output. So the starting value of the input is 0 and the higher value of the input is 1. Then in sine function, we are getting the starting value from -1 and the ending value as +1. Then in sigmoid function, we are having a starting values of a function is from 0 to 1, but here we are using the wave signature. That is, in step function we are having a stepwise assumption. Then in sigmoid function we have the curve lines as represented the output value of the function. Then here the data scientist uses the activation function to make a subjective decision based on various problem statement. and form the desired output. Activation function may differ in perceptron model by checking whether the learning process is slow and then exploding gradients. Then here we are going to see about the how does the perceptron works. In machine learning, the perceptron is considered as a single layer neural network that consists of four main parts as named as input values, then weights and bias, and then net sum and an activation function. The perceptron model begins with the multiplication of all input values and their weights. Then add these values together to create a weighted sum. Then this weighted sum is applied to the activation function f to obtain the desired output. This activation function is also known as the step function and is represented by f. Here we are basically using the activation function as step function. Then in this we are having a perceptron rule, that is here we are having input and then along with its weights then we have a net input function, that is summation of the input as well as weights. Then in activation function we are combining both net input function then and then bias, and then we get the output. So here we are comparing the value of the input and output, and then if any error is occurred means we are back through the values and then as input to the another perceptron, and then we are doing the work from start itself. So next, in this image, we are going to represent the values. That is, here we are giving the input from x1, x2 up to xm. Then the weights from w1, w2 up to wm. That is, each and every input has some weights. And then we are having a net function, that is summation function. So here we are combining the both input and weight, and then we add the both we add all the input along with its weights, and then we are giving the value to the activation function. Here we are using the step function as activation function. In this in step function we are having the values from 0 to 1, that is the minimum value is 0 and then maximum value is 1. Then in this step function we are using the net input function plus the bias of the particular details, and then it produces the output. And here the explanation of the before image. The step function or activation function plays a vital role in ensuring that the output is mapped between the required value 0 and 1 or -1 to 1. It is important to note that the weight of input is indicative of the strength of a node. Similarly, an input's bias value gives the ability to shift the activation function curve up or down. Perceptron model works in two important steps as follows. Step 1. In step 1, we are multiplying the all input values with its corresponding weight values and then add them to determine the weighted sum. Here we calculate the weighted sum as follows, that is summation of wi into xi, that is the weight of the input function and then value of the input, equal to x1 into w1 plus x2 into w2 plus up to xn into wn. Then here we are adding this special term which is called as bias, that is B, to this weighted sum to improve the model's performance. So here we are going to add the bias which is improve the model's performance. The final value of the net summation function is summation of wi into xi plus b. Then in step 2, in this second step, an activation function is applied with the above mentioned weighted sum. Here we are putting the weight input values along with its weights, and then adding the bias of the particular input values. And then in step 2 we are giving the activation function that is mostly used in step function, which gives us the output either in binary form or a continuous values. So the output may be in binary form, that is 0 or 1, or else continuous values, that is values which is from minimum 0 to maximum 1, or else we are using sine function means, so which is starting from -1 to 1. So within the limit we can get the values, or else binary form. Binary means 0 or 1. Then next we are going to see about types of perceptron models. So in this, based on the layers, perceptron models are divided into two types, which is single layered perceptron model and multi-layer perceptron model. Single layer perceptron model. In single layer perceptron model is considered as feed forward network, and it is also includes a threshold transfer function inside the model. The main objective of the single layer perceptron model is to analyze the linearly separable object with binary outcomes. So the main objective is to analyze the linearly separable object with binary outcomes. Then in single layer perceptron model, its algorithm don't contain recorded data. So it begins with randomly allocated input for weight parameter. Further, it sums up all inputs along with its weights. After adding all inputs, if the total sum of the all input is more than the determined value, the model gets activated and shows the output value as +1. If the outcome is the same as the predetermined or threshold value, when the performance of this model is started as satisfied, and then weight demanded does not change. However, this model consists of a few discrepancies triggered when multiple weight input values are fed into the model. To find this desired output and minimize error, some changes should be necessary for the weights in input. Then, multi-layered perceptron model. Like a single layer perceptron model, a multi-layer perceptron model has the same model structure but has a great number of the hidden layers. So what is the difference between single layered and multi-layer perceptron model? So each and every perceptron has its same 3 layers, but that is input layer, hidden layer and output layer. In single layered perceptron model has input layer and one hidden layer and then output layer. Then in multi-layered perceptron model, we have more number of hidden layers. Then as well as we have a input layer and then output layer. Then we have a more number of hidden layers. So in this multi-layer perceptron model, we are using back propagation algorithm. So in back propagation algorithm, it executes in 2 stages as follows. First one, forward stage and backward stage. Forward stage, activation function starts from the input layer in the forward stage and terminate on the output layer. Then in backward stage, weights and bias values are modified as per the model's requirement. In this stage, the error between actual output and demanded originated backward on the output layer and ended on the input layer. So in forward stage, as well as we are giving the input along with its weights and then put the both values and plus with bias, we are doing the activation function, then we can get the output. Then we compare the output value with the input value. So this is called as forward stage. Then after comparing the values of the output and then input, we can get the more difficult difference means we can change the bias and weights of the inputs, so which is come from backward stage. So we are having a 5, for example, we are having a 5 hidden layer means then from last hidden layer itself we are changing the input and weight of the input, then bias value, and then we are doing the activation function. So like this we are using the uh, we are changing the input value weights of the input value and bias, and then we are putting the values in the activation function. This is called as backward stage. So which both forward stage and backward stage is from back propagation algorithm. The propagation algorithm is used in the multi-layered perceptron model. Then in multi-layer perceptron model is one of the most commonly used machine learning method, which is consist of a multi-layer of connected neurons. Multi-layer perceptron is an artificial neural network structure and is a non-parametric estimator that can be used for classification and regression. So in multi-layer perceptron, which is used in artificial neural network to satisfy both the classification and regression problems. Then let's see the structure of a multi-layered perceptron. Here we are having a input layer and then hidden layers, then output layers. So the number of hidden layers is more compared to single layered single layered perceptron model. Then here from the before image we can see the input layer, hidden layer and output layer, and the output layer gives two outputs. Therefore the two output nodes, the nodes in the input layer take input and forward it for the further processing. The node of the input layer forward their output of the each of the three nodes in the hidden layer, and the same way the hidden layer processes the information and passes it to the output layer. Every node in the multi-layer perceptron uses a sigmoid activation function. The sigmoid activation function takes a real value as input and converts them to the numbers between 0 and 1 as a sigmoid formula. Here the sigmoid formula is A of G of H equal to 1 by 1 plus expression of minus beta into H. Here beta is known as the positive parameter. Then the values belongs between 0 and 1. So here we are using a sigmoid activation function. Then in multi-layer perceptron is also known as backpropagation algorithm. The stages is which is represented in the image format. Then here we are having inputs, weights, and then net input function, then activation function, and then we are getting the output. This is known as the forward stage. So as well as we are seen in the single layer perceptron model. So inputs along with its weights, then net input function, and then activation function, then it gives the output. Then here we use these inputs and the first level of weights to calculate the activation of the hidden layer. Then we use this activation and the set of weights to calculate the activation of the output layer. So now we have got the output of the network, and then we compare the output values and then target and then compute the error. So we can get the output, then what we have to actually need to get. So we have to compare both the values and then find out the error, that is known as compute the error. So backward stage, and in backward stage we are using back propagation of the error. So now we are obtaining the error and then we have to rectify it. So for this we are using back propagation algorithm, that is known as back propagation of error. So in back propagation of error is an algorithm that is designed to test for errors working back from the output nodes to input nodes. The error function that we used for the perceptron was, that is summation k equal to 1 to n, e of k equal to summation k equal to 1 to n yk minus tk. Here n is the number of output nodes. So the n is the number of output nodes, that is the node, how many nodes are presented in output layer. Then in the multi-layer perceptron algorithm, so it is called as MLP training algorithm. Using backpropagation of error is described below. An input vector is put into the input nodes. The inputs are feed forward through the network. The inputs and the first layer weights are used to decide whether the hidden nodes fire or not, that is work or not. The activation function is the sigmoid function given in, that is the function is g of h equal to 1 by 1 plus expression of minus beta into h. The output of these neurons and then second layer weights are used to decide if the output neurons will work or not. Next, the error is computed as the sum of squares difference between the network outputs and then targets. So what is the output of the network we are getting? By using the input values and along with its weights, then bias, then after we are using an activation function, and then we can get the output. Then we have to compare the output and then target values, that is what value we have to get exactly, that is known as target value. Then what is meant by output, what is value we can get using the input and weight and then activation function. So we have to compare both the output values and target values, then we have to find out the errors. Then we have to rectify the error. We are using the back propagation of error, that is back propagation algorithm. So in this, we have to use the formula E of t comma y equal to 1 by 2 summation k equal to 1 to n y of k minus t of k the whole square. This error is feed backwards through the network in order to first update the second layer weights and then afterwards the first layer weights. So we are going from backward, that is the output layer, then before the hidden layer and then before the hidden layer, before the hidden layer. So from we are coming the second layer weights, where we have to change the second layer weights and then we are doing the activation function, and then again we are doing we are changing the weight of the first layer weights, and then we have to apply the value, change the value into the activation function, then we can get the values. Then here we are next we are going to see about the advantages of multi-layer perceptron. It can be used to solve complex non-linear problems. It handles large amount of input data well, so it is easy to handle the large amount of input data. Then it makes quick prediction after training. The same accuracy ratio can be achieved even with smaller samples. So these are the advantages of multi-layer perceptron. So we are going to use the multi-layer perceptron model to solve the complex nonlinear problems, and then large amount of input data, then quick predictions, and then so have to get the same accuracy in, with the smaller samples. So we have to use this multi-layer perceptron as well as smaller samples and then large amount of input data also. Then disadvantages of multi-layer perceptron. It computations are difficult and time consuming. In multi-layer perceptron, it is difficult to predict how much the dependent variable affect each independent variable. So the difficulty of the analyzing the difference between the dependent variable and independent variable is somewhat difficult. The model's functioning depends on the quality of the training. So we have to do the more training and then only we can get the accuracy in output. Then next we are going to see about the applications of neural networks. So here we are by using neural network, we are doing more, we are having more applications, but here we are going to discuss about a few of them. First one is handwritten recognition. By using neural network to convert handwritten characters into digital characters, then that the machine can recognize. So we have to convert the handwritten characters into the digital characters, then the machine can recognize. So in this technique you are used in handwritten recognition. Next is stock exchange prediction. The stock exchange is affected by many different factors, making it difficult to track and difficult to understand. However, a neural network can examine many of these factors and predict the prices daily, which would help stockbrokers. Then currently, this operation is still in its initial phases. However, you should know that over 3 terabytes of data a day are generated from United States Stock Exchange alone. That's a lot of data to dig through, and you must sort it out before you are start focusing on even a single stock. So it is better to handle the large amount of input data. So we are in stock exchange is one of the main application of neural network. Then traveling issue of sales professional. This application refers to finding an optimal path to travel between cities in a given area. Neural network help to solve the problem of providing higher revenue in minimal cost. Then, however, the logistical considerations are enormous and we must find optimal travel paths for sales professional moving from town to town. Then image compression. The idea behind neural network data compression is to store, encrypt and recreate the actual image again. So image compression, the idea behind we have to compress the image and then store, encrypt and recreate the compressed image into the its actual stage. Therefore, we can optimize the size of our data using image compression neural network. It is the ideal application to save memory and optimize it. So it is used to save the memory and optimize it. So in application of neural network, we are seeing the handwritten recognition, stock exchange prediction, and traveling issue of sales professionals and image compression. Then we are going to see about the activation function, so which is we are already seen, but here we are going to see about somewhat detailed. So the activation function is act as a main purpose of the classification neural network, that is for prediction and analysis and all. Then already we are seeing the three activation function. In here, artificial neurons are an elemental units in the artificial neural network. The artificial neurons receives one or more input and then sum them to produce an output. Each input is separately weighted and then sum is passed through a function known as an activation function or transfer function. In an artificial neural network, the function that takes the incoming signal as input and produces the output signal is known as the activation function. So in this diagram, we are going to see the values are used in the perceptron. Here x0 equal to 1, x0 equal to 1, x1, x2 up to xn. Then this is known as the input. And then each and every input has its own weights, that is w0, w1, w2 up to wn. Then we have to summation it. Summation of I equal to 0 to n, w weight in multiply input wi into xi, and then these values send it to the activation function. And then in activation function we have to apply the function, specific function with the which is chosen based on the problem, and then we are adding BIOS and then we are giving the output. So here the function f can be expressed in the following form. That is here f is the function that is known as activation function. Y equal to f of summation I equal to 0 to n w I into xi. Then here we are going to see some of the activation function. First one is threshold activation function. In threshold, activation function is defined by f of x equal to 1 if x greater than 0, minus 1 if x less than or equal to 0. That is, we have to represent the threshold activation function in a graph format, which is starting from minus 1 and to plus 1. That is the minimum value of the function starting from minus 1 and then maximum value up to 1. Then unit step function. In this function, the threshold activation function is also defined as unit step function, in which case it is called a unit step activation function, which is defined as follows: f of x equal to 1 if x greater than or equal to 0, 0 if x less than 0. Here we have to represent the unit step function in the graph format. So with the value starting from 0 to 1, that is the minimum value starting from 0 and then maximum value from up to 1. Then sigmoid activation function, which is also known as logistic function. Here we have to represent the value f of x equal to 1 by 1 plus e power minus x. One of the most commonly used activation function is the sigmoid activation function. It is a function which is plotted as S-shaped graph. It is defined as the follows. The value ranges from 0 to 1. Then its nature is a non-linear. Then it usually used in output layer of a binary classification, where result is either 0 or 1, as the value of sigmoid function lies between 0 and 1 only. So result can be predicted easily to be 1 if value is greater than 0.5, otherwise 0. So we have to put the value, if it has above 0.5 means we have to put as a 1, or else we have to give 0. Then linear activation function. So in this linear activation function is defined by f of x equal to mx plus c. That is the line formula. F of x equal to mx plus c, which is known as the line formula. So here the graph is plotted as a line from the minimum value minus 1 and to the maximum value plus 1. So this defines a straight line in the xy plane. So the output belongs to the in graph representation, which is denoted as the straight line, because mx plus c is a formula of a straight line. Then next one is tan h, or hyperbolic tangential activation function. The activation that works almost always better than a sigmoid function in tan h function, also known as tangent hyperbolic function. It's actually mathematically shifted version of a sigmoid function. So it is a shifted version of a sigmoid function, that is update of the sigmoid function. Both are similar and can be derived from each other. The values from minus 1 to plus 1, which is also denoted as a non-linear nature of a function. So it is used in hidden layer of a neural network, as its value lies between minus 1 to plus 1. Hence, the mean for the hidden layer comes out be 0 or very close to it. Hence, helps in certaining the data by bringing mean close to 0. This makes learning for the next layer much easier. Then here the tan h of function is represented in a graph format. So the function f of x equal to e power x minus e power minus x divided by e power x plus e power minus x. The minimum value is from minus 1 and to the maximum value plus 1. Then ReLU activation function. It stands for rectified linear unit. It is most widely used activation function. It's implemented in hidden layer of a neural network. The equation is known as a of x equal to maximum of 0, x. It gives an output x if x is positive and 0. Otherwise, if the output is x, if which is positive means the output value is represented. If some otherwise, the 0 is represented as the output. The value ranges from 0 to infinity. So it's the nature of the particular function is also known as a non-linear which means we can easily backpropagate the errors and have multiple layer of neuron being activated by the ReLU function. So compared to other function, the most of the neurons are activated by using rectified linear unit function. So the uses of ReLU is less computationally expansive than tanh and sigmoid because it involves simpler mathematical operation. At a time, only a few neurons are activated, making the network sparse, making it efficient and easy for computation. Here, the values is represented from 0 up to infinity, which is represented in the graph format. Okay. Then that's it. So today we are seeing about the neural network, introduction of the neural network, and then the neurons, about the neurons, then perceptron, how the perceptrons are represented, replicate the neuron, and then the perceptron function, then perceptron rules, single layer and multi-layer perceptron models, and then the components of a perceptron, and then we are going to see about the application of artificial neural network. Then we are going to see some of the types of activation function. Then we have to working of a perceptron. So I hope you can understand this topic. Then again we are going to see about doing the other topic. Thank you.